I'm Andrew Armstrong and welcome to the back office. Today, earlier today, I tidied the office a little bit, and then there was a final thing I wanted to do, and that was, if you can see there, the rapid prototyping machine in the corner. I wanted to give it a bit of a hoover with the sort of Dustbuster type hoover we've got. But when I went to retrieve said hoover, it started to sound like this. So straight off the recharging station, okay, I could tell that someone had broken it, basically knackered it, and put it back without telling me. I don't know if that happens a lot in your household, but it does in mine. So it sounds to me that something inside is jammed because the blade isn't spinning. So we're going to try a new thing today. I'm going to try to keep the camera where it is and do a repair right here on the bench in front of me. There we go. Now, should be able to zoom this in. So you get a better look. And I'm going to turn the auto focusing off. So now, let's get some tools. And I'll begin. So I can see there's some screws here. I'm going to take these ones out. I basically want to get to the motor. There's a lot of screws in the side of this unit here. You can see these various holes. I'm sorry it's quite dark. It's a very dark purple, almost black unit. Right. So I'm going to take this bottom panel off because it may well be that whatever's causing this to be jammed up might be accessible. And I'm suspecting this door is really the battery door. Okay, it's quite stiff, but okay, so there's a bit of fur in there. What I'm going to do is shake this out. Okay. So you can see inside there looks to be a battery, sealed lead acid battery that doesn't want to come out. So I'm going to have to use a bit of brute force, I think. Nope. Oh, there we go. Okay, so it's just got normal terminals on it. I need to get it. Ooh. Okay, these look like they need a little bit more force, so I've got a pliers here. I'm going to just zoom out, give you a bit more to see. Okay, so a red wire on the positive terminal, so that'll be easy to put back. So what can we see? So inside the unit here, you can see there's a whole bunch of fur and fluff. So I'm going to try to pick that out with some tweezers. I'm aware as I'm walking away from you that my voice is probably getting quieter, so I'll try to avoid doing that in the future. So I'm just, I think I can get this with my fingers actually. Hair, fluff. More fluff. Okay, bits of tinsel. So going through the front there as well, I've got These are very expensive surface mount component tweezers. Try not to damage them. Okay, so let's have a go at putting this battery back in. No, still sounds pretty dead, and actually, uh-oh. I've managed to pull one of the terminals off as well. So what I'm going to do, before we go any further, put that aside. Grab one of my multimeters. Make sure in your, if you have your own back office, that you have at least 3 multimeters at hand. Preferably 3 multimeters, a couple of oscilloscopes, maybe a pocket oscilloscope as well. So, what can we see from here? It's supposed to be a 12-volt battery, so that'll be our first test. 11.3 volts. So, I don't think it's the fault of the battery here. Okay. I'm just going to get another terminal to replace this one I broke. Get rid of this ball of fluff now. We don't want to look at that anymore. Okay. This one's a bit too big. Okay, so the ones I've got are a bit too big, but I think they'll do. Just double check it does go on. Yeah, that's fine. I'm going to throw away the old one. The end of the cable looks fine. This is a blue terminal, so we'll use the blue dot on the tool to crimp it. If you can get the right place. Okay. Oh. Whatever you do, don't use these cheapo Poundland version of the crimp tool. I'm going to try with the pliers because this terminal is actually knackered now anyway, but let's see if we can get this pliers to get it to bite. Oh, it did bite. Okay, I do have better ones than these. I'm going to throw these away, I think. Right, okay, let's just try that one more time. Nothing. So it may well be that we actually blew a fuse in this unit by persevering when we should have given up. So it's time to delve deeper. If you're doing this sort of thing a lot, it might be worth investing in an electric screwdriver. We do have several here, but I'm a bit too lazy to go get one. Right. None of the screws fell out. Okay. I'm searching for any mystery screws I may have left. I think this portion of the handle actually is clipped on and has to be unclipped first, so I'm unable to prise it with my nail, so I shall look in my goodie. Here we go. So just a small micro screwdriver we'll use to see if we can prise that up somewhere. You can see I'm not taking much care. If this was perhaps an iPhone screen or a Nexus screen, it would be, but as it's something I suspect would be beyond economic repair, I'm not too bothered. Yeah, so that's starting to come off. Oh, there we go. That's out. I'm just working the plastic to try to figure out what's keeping it together. I suspect this main part of the body here along this seam has got some internal clips. So maybe I'll just try to... No. I'll have to look for those clips. Hunt them down. See a big switch there. It's quite tenacious. And it appears I've forgotten a screw in the middle. That'll be the reason. Whew, the amount of times I've done this. You'd think I'd learn. Always check for that mystery magic screw. Be it something like this, be it an engine, anything you're doing, you'll always find if you can't get them apart, there'll be one nut, bolt, or screw still in the casing. Right, I'm just, I've noticed there's two foam pads in here that are full of gunk, which these are acting as a filter. I'm wondering if someone used this without the filters. Just placing the filter back. Right. So what do we have? We have the motor, we have quite a sophisticated looking charge circuit here. There's actually a relay on it. Okay. I can see on the PCB some resistors have been cut off. That's interesting. I don't know. Maybe it was a revision on the PCB there. Let's try to pop our battery back on. Oh, cool. Now, when I switch the switch, you can actually hear the relay engaging. That's all very well and good, hearing the relay, but doesn't appear to be anything we can do with this circuit. Okay. Sorry, back playing with the zoom there. Okay, you know, for all intents and purposes, this unit's trash, so we might as well have a little bit of fun with it. So what I'm going to do is I'm going to disconnect the battery. Let's cut this fan motor off. There might be some interesting parts there. There's a nice, the relay sounds like it's still working. Very heavy power switch. So what I'm doing is I'm just bearing the motor wires. I think I can see what was wrong with this actually. In there, I'm going to just see if I can focus this up for you. Oop, no. Somewhere. Anyway, in there you can see that there's a bunch of hair. And that might have been all it is. Right, but let's see. Oh, nothing. The motor is dead. So it was the motor all along. And it's not a serviceable part at all. Completely knackered. Well, there you go. So don't be afraid to pull apart your next Dustbuster or Dustbuster type gadget. Unfortunately, in this case, the motor was damaged. And really, as you know, these motors are sealed and it's very hard to get brushes for them. So a bit of a shame, really. I suspect what's happened is some hair has worked its way into this. Maybe it was giving a bit too much resistance and the motor just couldn't handle it. So, thanks for watching. Oh yeah, just to add to the end of the video, I'm going to keep this. Look how cool this is. It's a huge battery. It's a 2.6 amp hour 12 volt battery. That's going to be useful for something. That'll live on my shelf. Okay, you can go away now.